Q22. This is really going to be very similar to what we were doing before. However, a few changes, and mainly the type of functions are not linear, but they are quadratic. So we'll see how that makes it a little different. First of all, for what our domain is, now remember, with rationals, we can't divide by 0. So this is we have to take anything out that would cause division by 0. Now, the denominator becoming 0 will make that happen. The numerator, we don't care about. It will be some number, but some number divided by 0 we can't have. So what we're going to look for is when is 3x squared minus 10x minus 13, when is that equal to 0? Now, a quick way to do it, I mean, we could factor and then set it equal. Another sort of quick way to do it is to use your graphing calculator. Okay, so we could graph this and find the x-intercepts, because where the x-intercepts are to this, to just the denominator, that will give us where y equals 0. So let me clear this out. So I'm going to go ahead and graph this as y equals 3x squared minus 10x minus 13. And decimals will tell us right away that occurs at -1 and 4.33. So that's 4 and 1/3. We'll kind of figure that one out. 4 1/3 is going to be 13 thirds, but 4 and because it's not that. Okay, so that's what we got. So we have that we need to take out -1. So we did it graphically. Let's do it this way. It was a little graph, and we found -1, and it's not really to scale, right? But we'll figure it out. If we do it with factoring, the way we would factor this is 3x times something, x times something. And we need a number that multiplies to give us 13. 13 is a prime number, and the difference is going to be 10 in the middle. So we can't take 3 times 13. That's going to be too big, right? That's going to be 39. So we'll put our 13 here and our 1 here. So 13 times 1 is 13. 3 times 1 is 3. So that makes that part work. This has a negative saying that we're going to be subtracting. So 1 is negative and 1 is positive. The negative in the middle says that the bigger number has to be negative. So this is all these factoring things we need to do. So here's another way to do it. And what you see is that we get x plus 1 equals 0. That's one option. Or 3x minus 13 equals 0. Solving for x, we subtract 1 from both sides. We get that x equals -1. That's what the graph told us. Over here, we add 13 to both sides. Then divide by 3. X equals 13 thirds, which is 4 and 1/3, or 4.333, which is the graph also told us. Okay, we'll probably just use this one. So what is the domain of this function? Again, we draw a number line. We can use any x value from -infinity to +infinity except for -1 and 4.333. Those are the ones we have to exclude, right? We're excluding them. So the way we're going to write this is, and I'll just do it down here, is we go from -infinity to -1. Union, then we can go from -1 to 4.33, or 13 thirds. Maybe we should use that. I don't know. Both are the same, sort of. Not really, because 4.33 is not exact, but 13 thirds is. And then we union 13 thirds all the way to infinity. Okay, so that's going to be our domain, everything except for those two x values. While we're here, let's go ahead and they want to sketch the graph, so kind of remember these things. What is the vertical intercept? Well, remember, vertical intercept happens, it's a y-intercept. It happens whenever x is equal to 0. So what we do is we find the function value when x is 0. So we get 0 squared minus 4. We get 3, 0 squared minus 10 times 0 minus 13. Well, what does that mean? Well, this is 0, this is 0, this is 0. It's negative 4 over negative 13, which is positive 4/13. And again, that is a point. X is 0, y is 4/13. What are the zeros of this function? Again, we're going to have to set it equal to 0. And if you remember from last time, maybe you didn't watch the last one, but the only way this is going to become 0 is if the numerator becomes 0. And then the denominator would be non-zero, right? So we can't have negative 1 or 13 thirds. But we're looking for where is the numerator 0. Right? So zeros of the functions, when does the numerator become 0? A couple ways. You could add 4 to both sides and then take the square root. So if you add 4, get 4 equals x squared. If we take the square root, the thing you have to remember is that when you take the square root, you get both a plus and a minus on this, because when you square something, a negative squared is positive and a positive squared is positive. So we get plus or minus 2 is what x is. So really two answers, x equals negative 2 or x equals positive 2. So those are the zeros, or the x-intercepts. Horizontal asymptote, we'll do this one maybe down here. For horizontal asymptotes, we're just concerned with the two largest degrees, which is x squared and 3x squared. All of these, and because the horizontal asymptote is kind of answering these same questions here, as x gets really, really big, the only things that matter are these largest terms. These other ones are so small they don't really make a difference. So what we get to analyze for the horizontal asymptote is we get to think of this as x squared over 3x squared. That's all we have to do. Y equals that. That's going to be our horizontal asymptote. X squared divided by x squared cancels. So that's 1 over 3. It's y equals 1/3. The horizontal asymptote, y equals 1/3. Vertical asymptotes, well, we've actually already found those when we found the domain. So when we're talking about the domain, remember, we found that we can't have x equals negative 1 or 3/13. Those were the two that were causing us problems, these two. So those are also going to be our vertical asymptotes. That will be when x equals negative 1 or x equals 13/3. So I don't have to go all through that, but so whenever I'm answering the question about the domain, I'm answering the question about vertical asymptotes at the same time. Vertical asymptotes are actually not part of the graph. They're the places that it gets away from. And then now when I look at this, the limit as x goes to infinity, we were actually answering that when we got the horizontal asymptote, right? Y equals 1/3. So what's going to happen when x goes to infinity? Well, the y value, the output, is going to go to 1/3. When it goes to negative infinity, same thing's going to happen. That horizontal asymptote is going to be the limiting factor in both directions. Now we can sketch this graph. What I'm going to do is I'm going to go ahead and use decimals again. We'll put this in here, and we'll be able to put in both the horizontal asymptote, the vertical asymptotes, and we'll see how this graph fits right in there. So what I'm going to do, let me just kind of bring part of it over here. Let's see if it'll let me do that. Not really, huh? Let's see. I think what I can do is I can shrink it up this way. And so what we're going to do is we'll put in the function parentheses x squared minus 4 divided by parentheses 3x squared, arrow over, minus 10x minus 13. So that's our function. And before I go too much further, what I'm going to do is, oops, what happened there? Let's recover real quickly here. X squared minus 4 divided by 3x squared minus 10x minus 13. Okay, do that. I'm going to put in the horizontal asymptote, y equals 1/3. And we'll put in the two verticals as x equals -1 and x equals 13/3. I'm going to change these all to, we'll leave them as blue, I guess. But we will make them dashed lines, hopefully. So a dashed line, and we'll make it blue. Dash line, and this will make click and hold. Come on. Come on. There we go. And then now when I bring the graph over here, I'm going to have to erase everything else. Remembering our x-intercepts of -2 and 2. There we go. +2, -2. A y-intercept of, what was our y-intercept? Our vertical intercept, we came up with 4/13. And I guess if you divide 4 by 13, you get 0.308, close to 1/3. So let's again, you probably hopefully have all this written down. And so you should have a graph that looks something like that. But you see how it fits. Now, this horizontal asymptote, yes, this middle part actually does go through the asymptote, but its asymptotes are for the long-term value. So as x goes out to -infinity or +infinity, that's where the horizontal asymptotes come in. Vertical asymptotes, notice the function does not exist at those 2 points. Okay, and we have all the other ones in there. So again, using a graphing calculator is a very helpful way to do it first, and then you've also got the analytical way that we had of getting through it.